And now we're here back on Monday for another attempt. Hopefully today we will have some better luck for the attempt. Again, everything going well so far. We're under 37 minutes to go. ELaNa, how are things looking from the technical side of things?
So far, everything continues to appear nominal. We are checking off the steps in our countdown procedure, and kind of the next major milestone that we anticipate is some software configurations at around T-minus 30 minutes before we step into our final preparations and our terminal count.
Great to hear. We've got some more questions in the queue, so let's see what's coming up next. A question, does performing static fire tests put an additional strain on the rocket before launches?
That's a great question. So if you are not familiar, one of the final preparations that we complete is a static fire test of the vehicle, which means we essentially go through everything exactly as we will on launch day, with the exception of letting go of the rocket. So we light all 5 of those Delphin engines and run them for several seconds to verify that everything is working as it should, and then we shut down everything, and that is one of our final steps in preparing for launch. So the rocket is designed specifically to be able to handle this test in addition to multiple launch attempts. So it does not cause any issues because the system is designed to be capable of that.
That's good, and that's even though this rocket is a one-time use rocket. It's an expendable rocket, but the engineers, when designing the system, designed it for multiple cycles of fueling, pressurization, and engine firing, right?
Yes, that's correct. So we design our system for multiple tests and to be able to go through all of the necessary launch preparations with margin, and including that static fire test.
I believe we actually have a video of that static fire test. Michael, can we show that?
10, water on, 8, 7, 6, 5, 4, 3, 2, shut down.
And again, that was completed last week, I believe, and that actually ties back into our next question here, because Khalid asked, how much time does it take to set up a launch pad for Astra?
That's a wonderful question. So everything that you see that is not, part of that fixed infrastructure of the pad, there's some lightning towers, there's some lighting fixtures that you can see. Those all stay on the pad, but everything else we bring with us, and we can really set up a pad in a matter of days with a red team of about 5 folks who are on the ground setting up everything. So we really design our system to be as nimble as possible, and like we've mentioned before, everything fits inside shipping containers and can be set up by a very small team in a very short amount of time.
There you go. We have 2 questions next coming up that I'm actually going to combine into one question because I feel like they go together. One person is asking, do we know much about today's payload? And then the other question is, how does this improve life on Earth? So, ELaNa, can you talk about these missions and how they're improving life on Earth?
Sure. So there was a brief intro video that we showed at the top of the broadcast, but there are 4 teams that have each have a CubeSat aboard today's mission. They come from the University of Alabama, Tuscaloosa, University of California at Berkeley, New Mexico State University, and NASA's Johnson Space Center. So I can talk about each of those 4 spacecraft a little bit. BAMA 1 is from the University of Alabama, Tuscaloosa, and it's a technology demonstration mission that will demonstrate a drag sail module and rapidly deorbit the satellite. And this helps reduce space debris and reduce the risk to operational satellites, space stations, and crewed vehicles, which is really interesting and exciting. INCA, which stands for Ionospheric Neutron Content Analyzer, is from New Mexico State University. It's a scientific investigation mission that will study the latitude and time dependencies of the neutron spectrum in low Earth orbit for the first time. And the purpose of this is to improve current space weather models and mitigate threats to space and airborne assets. And it the measurements come from a brand new directional neutron spectrometer, which is being developed in conjunction with NASA's Goddard Space Flight Center and the University of New Hampshire. CubeSat, with a Q, is from the University of California, Berkeley. It's a technology demonstration mission that will test and characterize the effects of space conditions on quantum gyroscopes using nitrogen vacancy centers in diamond. And these nitrogen vacancy centers are defect points in diamond with quantum properties that allow scientists to form gyroscopes that measure angular velocity. So these technologies are well suited for space because they are very accurate, small, and tolerant to radiation. And our fourth payload is R5S1 from NASA's Johnson Space Center in Houston. And it is intended to demonstrate a fast and cost-effective way to build successful CubeSats, in addition to demonstrating some technologies that are important to in-space inspection, which could help make crewed space exploration safer and more efficient. R5S1 could prove a cheaper way to demonstrate crucial technologies like high-performance computers, cameras, algorithms, and a new way for satellites to transmit pictures to the ground. And so those are four very different spacecraft on board, but they all have very exciting missions that they are going to conduct. And the second part of that question is really, how do these improve life on Earth and getting better weather information, getting more technology from high performance computers, making those spacecraft more accurate and able to deorbit more easily to protect other spacecraft and be responsible stewards of space. Those are all really important missions that maybe you won't notice in your day-to-day life, but they definitely make an impact. So we're very proud to be selected as the launch provider for this mission and these four incredible payloads.
Absolutely awesome to hear about those payloads, and if you ever want to know how smart the people working on these spaceflight missions are, just read about their payloads, because there's some really cool stuff in there. We've just passed the 30-minute mark, and I actually want to cut it over to the countdown net because the teams are actually moving into the final software load. So let's listen in to Chris Hoffman and the rest of the launch team.
Tango and AV1 manage polling. Toggle do only ground polling.
Toggling do only ground polling.
Okay, this takes us into step 119, loading late load configs. Delphin, are you ready?
Dolphin is ready.
Please provide.
Okay. Igniter is 180.
Loading config 180 Victor 3 on the igniter controller. Load.
Engine Alpha 174.
Loading config 174 Victor 1. Load.
Engine Bravo 175 Victor 1.
Loading config 175 Victor 1. Bravo. Load.
Engine Charlie 176 Victor 13.
Loading config 176 Victor 13 on engine Charlie. Load.
Engine Delta 177 Victor 13.
Loading config 177 Victor 13 on engine Delta. Load.
Engine Echo 178 Victor 15.
Loading config 178 Victor 15 on engine Echo. Load.
Ether, please provide your late load config.
Their config 183 Victor 7, please.
Loading config 183 Victor 7 on Ether. Good load.
And GNC, please provide an updated guidance config for us.
Victor 143.
Loading config 5 Victor 143 on guidance. Good load.
Copy. Good loads and all late load configs. Per step 120 Tango in VB1 turn on off PDBs. Please give me a GNC setup.
Toggling GNC setup.
The teams have finished their late load configs for all of the engines and as well as the guidance system, so that's another milestone checked off the list. Now coming up on T-minus 26 minutes and counting, and everything is still on track for an on-time liftoff. Again, the launch window opens at 1 o'clock p.m. Eastern Time, and everything on track right now. In the meantime, we've got some more questions, so why don't we head that way. Carolina, my next question, this is the first launch from Cape Canaveral, Florida, and that means reaching some different orbital inclinations, because we touched on this during the last broadcast over in Kodiak, Alaska, how different launch sites lend themselves to different orbits. Can you talk a little bit about that?
Sure. So, yes, Thomas, you're exactly right, as you just mentioned. One of the things that helps determine which orbits you have access to in space is the location where you launch from, in particular the latitude. So Kodiak, very far north, is great for reaching higher orbits like polar and sun-synchronous orbits. But a lot of spacecraft want to be closer to middle inclinations for a number of reasons, for tracking weather, for being communication satellites that want to be over more populated areas of the globe. So the Cape Canaveral location is great for reaching some of those mid-inclination locations. So today's mission will be heading to an inclination of 41 degrees and an altitude of 500 kilometers. Great. So just to recap, the Cape Canaveral location will help us provide our customers with access to new destinations in space, and we are very grateful to our partners for helping make this launch possible.
And a bit of orbital mechanics to go along with that. Sometimes if you have a mission that the inclination maybe isn't as important to the mission and other factors for the orbit are more important, you might want to launch closer to the equator, because it is actually simply easier to reach orbit in the first place if you launch closer to the equator, such as Cape Canaveral, because you get a little bit of extra boost from Earth's spin. So that's another factor that plays into how the launch sites are chosen for different missions. But speaking of that, this is the first Astra mission launching from Cape Canaveral, like we just talked about. Also the first Astra mission to deploy payloads into orbit. So those are very big historical milestones for Astra. But we also wanted to just pay a quick tribute to another historical space happening that happened in space history today. Right, Carolina?
That's right. On February 7th, 1984, so 38 years ago, NASA astronaut Bruce McCandless II became the first human being to walk in space untethered. McCandless stepped out of the Space Shuttle Challenger and into nothingness. As he moved away from the spacecraft, he floated freely without any earthly anchor. And if you've ever seen those images of an astronaut floating in the blackness of space above Earth, that is the spacewalk that we are talking about today. 38 years ago today, that incredible image was taken.
And you hear that, everybody in chat? There's the shuttle reference of the day. We've got there. It only took us a little under 40 minutes, but we got to the shuttle reference. It's an NSF stream. We have to. It's a rule. Moving on, we've got another question to talk a little bit about the mission controllers who are controlling the countdown. Like I mentioned, Chris Hoffman is our flight director, but there is a team at Astra in Alameda who is behind today's launch. And Carolina, can you give us an introduction to the team today?
Sure. So we have our team here at Mission Control. They are sitting directly behind me when my camera is on, but they are right behind me. Starting with Chris Hoffman with the Mohawk. He is our flight director. Hill Hudson is our flight activities officer, or FAO, with that googly-eyed console. Chris May is our command and data handling officer. And Claire Gauthier in the orange sweater is our Tango, who's our vehicle controller, who's actually the one that you hear, loading the software configurations onto the computer. Christopher Rossi, the Wind Destroyer, is our GNC representative today. And then finally, we will have our flight safety FTS person, Rose, who seems to be up from her desk at the moment.
And you'll see those teams working throughout the rest of the countdown and during the flight today. Again, 21 minutes and counting. All systems go right now. Those are the personnel in Alameda, California at Astra's headquarters. There are also some other members of the team here in Cape Canaveral, right, ELaNa?
Yes, that's right. So on the ground in Cape Canaveral, we have a team, a very small team. We're known as the Red Team. Ryan Hirschfeld is our safety officer. Adam Frisch is our Red Lead. Robert Freeman, Eric Larson, Sam Hirschap, Benjamin Whelan, Rusty Haller are our Red Team. And then we have Eric Steinberg and Thomas Cannon, who are our IT folks on the line, which we are thankful for all of your help in setting up our systems and hope you're enjoying the Florida weather, which is much nicer than it would be in Kodiak in February. And in addition to helping us be nimble, it has also helped us limit travel to have such a small team on site, which has been a key consideration during the ongoing COVID-19 pandemic. All members of the team are taking regular COVID-19 tests to protect the health and safety of everyone involved in this mission.
Excellent. As we come up on 20 minutes and counting, the teams are working through some additional steps in the countdown. ELaNa, can you just give us an update what the teams are working on now?
Sure. So we are about to step into our go, no-go poll to get into our terminal count. And essentially the team is just confirming that all of the systems are ready for launch, that our winds look acceptable. And in just a few minutes here, we'll see our water deluge test, and we will step into our terminal count from there.
That water deluge test is a very visible sign that the countdown is proceeding and getting towards that terminal count. You will not mistake it when it happens, and we'll draw your attention to it again in a couple minutes here. Before we get into that, I'll take a couple last-minute questions before we really get into the business end here. Nico asks, what material is this rocket made of?
That's a great question. So one of the things that makes our system unique is we try and use very simple materials. Much of the first stage you see is made out of aluminum. We try and stay away from carbon fiber and any really fancy aerospace grade materials, and that allows us to manufacture quickly and cost effectively so that our customers can have the best access to orbit that they can have.
And that's a trade-off, right? That's a trade-off between the cost of manufacturing and producing those vehicles and the performance they give. And in order to use cheaper materials, you have to design it so that obviously the vehicle will still perform as you need to.
Right. It's something that we're constantly working towards and trying to push the envelope with what we can get out of our vehicles.
There you go. So I'm seeing some notes in chat that mission control in Alameda is approximately 50% Chris, and we have a thing in NSF where a lot of people named Chris as well. So there's this trend going on between Astra and NSF. I wanted to note that in chat, and I appreciate the comment.
Yes, we do have quite a few Chris's, but what you're not seeing when we see that mission control is that we also have the engineers, the responsible engineers for each of the systems that you may hear on and off comms as we switch to the countdown. They're distributed throughout our factory at their normal desks, who are monitoring their systems. And there aren't too many Chris's in that group on the rest of our comms. So a bit of a high Chris sample in that mission control shot.
There you go. Got to have a larger sample size for a more representative, a better representation of the team, for sure. Again, T-minus 17 and a half minutes, and we are coming up on that water test. You'll see, actually, Carolina, why don't you talk about what are we going to expect with this water test coming up?
Well, I believe I actually just heard that our water system is correctly configured and does not need to go through that test at the moment. But if you joined us earlier and saw that static fire video, there is a large plume of water that shoots out from the base of the vehicle, and that's for fire suppression and making sure that nothing on the ground close to the vehicle is ignited when we light those 5 first stage engines. So we will look out for that water deluge in the final moments of our terminal count.
The launch team is doing that thing where they make me look silly again, just say, oh, we already tested it, it's good to go. We're not going to do the fancy thing that you just alluded to. But it's fine, whatever, it's okay. Alright, so we're coming up on just a minute and a half again. Again, at that 15-minute mark, we're going to expect a final clear to launch pool. Actually, at around 60 minutes, excuse me, we'll be into the terminal count at T-minus 15 minutes. So in a couple seconds here, let's go ahead and listen into the countdown net as flight director. I'm sorry, take that back. Did I have the time wrong? I think I might have. We will stand by for the poll in a little bit. My apologies. Some other steps going before there. But either way, we're coming up on terminal count at T-minus 15 minutes. In the meantime, let's go back to some more questions then. If you have questions, tag us with @NASA Spaceflight. And our first question, oh, this is going to set up Michael nicely. Are there any cameras on the rocket, says Henny?
Yes, Henny, we have lots of onboard cameras, and we hope to get some great views of them during our flight today. This is a gray view from one of our cameras, which will hopefully turn into a much nicer shot. But we do have
some venting going on there. There you go.
Here we go. This is a great view of the upper stage. This kind of top right part of the screen, that's the fairing. So we will see that fairing open up. And the payloads deploy during our flight.
We'll of course be looking into those onboard views as well, and there's a great view of the payloads. You can actually see their payload deployers mostly. The CubeSat deployers, the CubeSat sit in a deployer on top of the upper stage, and hopefully once that fairing separates and the rocket is up into orbit, we should also hopefully get to see them flying away, which will be very cool. But those are those 4 CubeSat payloads ready for their ride to space just about 15 minutes from now. All right, and as we enter 15 minutes, Carolina, do you want to give us an update on what the teams are going to be working through now leading up to that terminal count poll that's coming up in a few minutes, and then the final steps of the countdown?
Sure. So in just a few moments, we'll listen into that go, no-go poll. Right now, the team is working through the final preparations, and we are going to move into the last steps of our countdown, which include making sure that all of the systems continue to be nominal, and then we will hand over the vehicle to internal control in the last moments before flight.
Absolutely. And for those who are just joining us, let's do a brief recap of what we're about to watch as well. Again, this is the ELaNa 41 mission for NASA. It is the first mission that Astra is launching to deploy payloads into orbit, and also the first launch that Astra is conducting from Space Launch Complex 46 at the Cape Canaveral Space Force Station in Florida. The mission is also called VCLS Demo 2, which stands for Venture Class Launch Services, NASA's dedicated small-sat launch services program. And the 4 payloads on board, 3 of them are from different university teams from the University of Alabama, University of California, Berkeley, and New Mexico State University, as well as a 4th payload from the NASA Johnson Space Center. All of those payloads were selected through the CubeSat launch initiative from NASA and sponsored to be put onto this mission. And that is, of course, why you see that beautiful NASA meatball logo on the payload fairing today, indicating that today's mission is for the American space program. And as we come up on 13 minutes here, teams are going through the last couple of steps that precede the go, no-go poll. And we'll be listening into that in just about 2 minutes here. Meanwhile, visually, you're seeing the rocket on the pad. You can see the tank, the one tank getting frosty, and the lower tank below it. Carolina, I believe that is the kerosene, the kerosene tank on the bottom, which is at mostly ambient temperature. You won't see any frost on that. But the liquid oxygen tank above it is super cool because obviously oxygen is not liquid at ambient temperature. So that's why we're seeing that frost on the vehicle, right?
Yes, that's right. So that sort of middle third of the vehicle is actually the same sort of silver color that you see in the bottom part of the vehicle, but it is covered in a coat of frost from that very, very cold liquid oxygen. And so our propellants on both stages are liquid oxygen and kerosene. We use RPX, which is essentially a highly refined form of kerosene or mineral spirits. and together with they move through our engines and generate the force to get us to orbit.
And then above that, of course, there's the interstage with the Astra logo and the U.S. flag, which contains the sort of the bottom part of the upper stage, and then payloads on top, and that payload fairing. All right, let's go ahead and listen to the countdown net as we are getting close to the continuing terminal count, and let's listen to the teams as they continue to work.
Astra is calling a hold at this time.
Thanks for standing by. As you heard, we are in a hold right now. The team is looking into wind limits, and of course, you know, the weather conditions can change pretty unpredictably. So we're keeping an eye on that, and we expect to have more updates for you shortly.
And again, for those who are joining us from earlier in the broadcast, today's launch window does extend till 4 o'clock p.m. Eastern Time, so there's plenty of time to resolve this hold, and the clock stopped at just 11:46, so still pretty late in the count. They should be a quick cycle back and go again once these issues are confirmed to be resolved and ready to go. But we'll provide those updates as soon as we have them.
That's right, and we also just heard on comms that the vehicle continues to be nominal, so we are just waiting on these last final issues. We'll likely reset the clock to probably around T-minus 15 minutes when the hold is released.
Okay, and we are still waiting to hear back about the status of this hold. We'll provide that update as soon as we have it. Hopefully will be resolved soon. But in the meantime, let's take some time to take a couple more questions here. And Musical Wolves in chat asks, is this the same launch pad equipment as Kodiak or new pad equipment for Cape Canaveral?
That's a wonderful question. We use the same equipment at our sites with modifications as needed for different little quirks that each range will have. So this equipment is designed to be compatible with Cape Canaveral, but otherwise it is identical to the launch equipment that we would use in Kodiak.
So that means they're going to be shipping different sets of equipment to different ranges. Like you don't take the one launcher, reconfigure it, and then send it to Cape Canaveral, and then reconfigure it back if you're going back to Kodiak or something like that. They need to be separate sets so that you can also be launching from different campaigns from different sites at the same time, right?
Right. If we, of course, if we're launching from different sites at the same time, we can't be
It
in
would
two
be
places at
difficult.
once. But yes, the system is designed so that we can make those configuration changes and use it interoperably at our different launch sites. So theoretically, there's nothing to prevent us from sending this precise set to Kodiak.
Gotcha. Thank you. Another question here from Caleb says, why does it look like there's smoke coming out of the rocket? I don't believe that's smoke. I believe it's actually condensation, right?
Yes, so you can see that there's some sort of condensation looking almost like steam coming off the vehicle, and then you can see those vent lines that are look to have a little bit more oomph to them than just the condensation that's evaporating off the vehicle. And so those are our venting system just ensures that our tanks are maintaining the appropriate pressure while the vehicle is being operated.
And by proxy, those vents also help maintain different temperatures, because if you're up on your chemistry, changing the pressure will change the temperature in the tanks. So you can also use that to control your thermal conditions on board the rocket. It's kind of a neat physics thing that is used to make sure the rocket is at the right conditions for flight.
Yes, that is exactly right.
Got another sort of question here from Sebastian, who asks, how do the rockets using liquid fuel get fuel into the engine in microgrid without it just floating through the tank?
That's a great question. So that mostly affects our upper stage engine. Our upper stage ether engine is a pressure-fed engine, so actually the pressure inside of the tanks itself is the propellants flowing to the engine in space.
There you go. And then another question, engine question. Isaac is asking, how much thrust do the engines generate? And that depends on which engine we're talking about, right? Because there's two.
Right. Well, technically there's 6.
Well, two different types of engines. My apologies.
Right. There's 2 different types of engines on the vehicle. So our first stage is powered by 5 Delphin engines, which each produce 6,500 pounds of thrust for a total of 32,500 pounds of thrust on the first stage. They are electric pump-fed engines. And the upper stage is powered by 1 ether engine, which is, as we just mentioned, a pressure-fed engine that produces 740 pounds of thrust. And both stages are filled with LOX and kerosene, so we have the same propellants on both stages.
There you go. And then also another question here. We actually didn't address this yet. We should talk about the range asset, which caused an issue on Saturday's attempt, asking about that. Can we talk a little bit about how that was resolved and prepared for today?
Right. So there was an issue with the radar system on Saturday. It was an asset that is on the range, and thankfully we were able to resolve that issue yesterday and prepare for today's launch attempt. So that the issue that caused Saturday's scrub will not be a problem today.
Glad to hear. And again, that's a partnership with the range here at Cape Canaveral. Space Launch Delta 45 is the Space Force wing, which oversees the Cape Canaveral Space Force Station. And that includes the range tracking assets and things that are used by all launch providers here at Cape Canaveral. So an important partner there. Another question here asking, how are these missions going to be affordable if the rockets are not reusable? They're expendable single-use vehicles.
Yes, that's a wonderful question. So reusability is only one piece of the equation when it comes to cost. The ways that Astra focuses right now on cost is using simple materials. We stay away from a lot of composites and fancy aerospace types of materials, and we use a lot of automation in our systems. As we've mentioned before, it takes very few people to operate one of these vehicles to set up our launch site. The team that is developing the vehicle is a very deep bench, but to actually conduct our launch operations is a very small group of people. And so those are some of the ways that we focus on keeping costs down with our launch vehicle.
Got it. And of course, there's also mass production, right? Because the eventual plan is to be launching so frequently that your production cadence will bring down sort of your overhead costs, and that's a manufacturing quirk that affects these expendable vehicles as well.
Yes, exactly. That's right. We hope to mass produce these vehicles, and that is definitely one of the ways to bring down the cost. We pride ourselves on making our system as simple as possible to build and scale, because we hope to provide almost unlimited access to space for our customers.
Gotcha. Also seeing some questions in chat again. If you have just joining us, the teams are currently in a hold right now, looking at some wind data and making sure that those issues are resolved prior to proceeding with the count. We're expecting some sort of recycle here prior to resuming the countdown. And we'll give you updates as soon as we have them. But right now, we're continuing to take some questions as we wait for a resolution. Again, the launch window, continues until 4 o'clock p.m. Eastern Time. So we have just under 3 hours to go before the end of the window. Plenty of time. But questions, if you tag us with @NASA Spaceflight in chat, we'll be able to see those questions through some software that Michael wrote. Thank you, Michael, producing the streams as usual. And we'll go ahead and answer as many of those as we can over the course of the broadcast. We've got ELaNa Grossman from Astra, the expert in the field. I'm just here to relay questions realistically. But let me see what other questions we may have. We can maybe talk a little bit about the planned flight profile for today. What are the kind of milestones once the rocket is ready to lift off we would expect to see as the rocket ascends and proceeds towards orbit?
Yes, that's a great question. So we are, again, we are currently holding, but once we set that new T0 time, just a few seconds before liftoff, the first stage engines will ignite. At T0 seconds, that will be liftoff. A few seconds later, the vehicle will begin its pitch-over maneuver, and we expect to reach max Q at around 1 minute and 10 seconds. So that's the point of maximum aerodynamic pressure on the vehicle. It's a significant milestone for us. Around 2 minutes and 50 seconds, we have MECO, or main engine cutoff, and then in very quick succession, we have the fairing at 2 minutes and 55 seconds, stage separation at 3 minutes, and then the upper stage ether engine ignites at approximately 3 minutes and 5 seconds into flight. It runs for about 5.5 minutes. At that point, we will have SECO, or second engine cutoff, and then finally we will have our payload deployment. This will be our first mission with deployed payloads at 8 minutes and 40 seconds, and so we will be deploying the 4 CubeSats aboard today's mission. And at that point, if we have achieved all of those milestones, we will be very excited to have completed the primary objectives of our flight and have achieved mission success.
There we go. And a question about those payloads, again, if you are just joining us, asking about what the target orbit and the payload sizes on board today's flight. So the target orbit is inclined 41 degrees at an altitude of 500 kilometers, and you can actually see from an onboard camera there that those CubeSat payloads are sitting in their deployers. They're 3U CubeSats sitting on top of the ether-powered upper stage of rocket in that payload fairing right now. And of course, we are hoping that those payload fairings will separate out in space, and those payloads will be able to be deployed after a successful launch soon. So staying tuned for that. Again, we're in a hold right now, but stay tuned for further updates. But those are those payloads, and I love those onboard views giving us a glimpse into the payloads just anxiously waiting their ride to space. Another question here, Matthias is asking, how's the weather looking now? Looks too scrubby? No, I don't think so. Weather is actually green right now, right, ELaNa?
Yeah, I believe we are. The weather is looking good at the moment, and we are hopefully awaiting some news about releasing this hold soon.
Absolutely. I know they were looking at those wind limits to make sure that they are going to remain green and stay where they need to be. So we're going to keep an update on that and make sure that they're all ready to go to release this hold. And again, stay tuned for updates on that. But keeping on with some questions here, William says, where in the countdown do you hand off to the flight computers?
Yes, so the handover to the flight computers happens in the final moments before launch. You'll hear, once we're listening to the countdown net, our flight director, Chris Hoffman, call out vehicle is on internal control. That's at 60 seconds before T0. So you can listen and hear when that milestone in particular takes place.
Gotcha. Again, we're staying tuned for further updates, but right now keeping going with some questions, so tag us at NASA Spaceflight and we'll try to answer as many of those as we can. We did talk about the flight profile, and actually I want to highlight this because Rocket 3 is a little bit unique in that payload fairing has to separate before the upper stage actually separates, right?
Yes, that is correct. Our fairing separation happens right before stage separations, but these milestones, we just talked through the mission timeline between main engine cutoff and the upper stage ignition. We run through some significant milestones in just 15 seconds. So we have our main engine cutoff, fairing separation, stage separation, and then the upper stage ignition, all within 15 seconds of each other in pretty quick succession.
And again, we are continuing to stand by for further word of the status of today's countdown, and we'll stay tuned, stay by for further updates, and we'll provide them again as soon as we have them. The team's working through them right now. All right, everybody. Thank you for your patience. The teams are still in a hold right now, but I believe we have an update from the status of the countdown. So, Carolina, what are the teams working on right now?
Yes, Thomas, the team is still looking at some wind data and reviewing that, where we try and get the latest up-to-the-minute information and run through simulations to make sure that everything will be okay despite the changing conditions. So that is what the team is reviewing right now. We are optimistic that we'll be able to continue with our launch countdown shortly. So in the meantime, we are still holding. So thanks for your patience and thanks for bearing with us.
Didn't want to come on and talk about something when we didn't have an update, so we went and got that update first. Thank you all for staying tuned, and again, more updates forthcoming as soon as we have them. But we do have some more questions in the queue, so we can go back to that if you'd like. And right on cue, we're talking about releasing this hold, hopefully before too long. Mist does ask, what is the decision-making process like to resume a countdown once you've called a hold?
So we will take all of the information from the issues that we've been troubleshooting and verify that we have not encountered any new issues. For example, if we hold too long, there may be certain blackout times specifically that we'll need in order to avoid colliding with another object in space. And so we'll coordinate with the range to make sure that we can set our new T0 time, and we'll proceed with picking up the countdown.
And on the same topic there, Noah asks, when does this window close? 1600 EST, that is correct. 4 o'clock p.m. Eastern Time, which is, if I do math in my head, 2100 UTC. Had to do that in my head real quick, thank you. But that is the end of the window, so plenty of time, 3 hours to go. And as you can see, the terminal count starts at 15 minutes prior to launch, so there is plenty of time for the teams to resume the count once that wind data is verified to be nominal and that the teams will be ready to go. So no worries just yet. Another question here, Al asks, after main engine cutoff, or MECO, what happens to the first stage of the rocket?
Right, so MECO stands for main engine cutoff, and that's the point where the first stage engines will have done their job, and they will be shutting off because we have run out of fuel. So after that point, once we separate the stages, the first stage will fall back towards Earth. We work very closely with all of the relevant authorities to make sure that there is a safe area in the ocean for the first stage to fall back to Earth, and it lands in the ocean.
All right. And then a similar question, moving on later in the flight profile, how long does it take for the rocket to reach its final deployment as Alex? So how long before those payloads are in a stable orbit along with that upper stage and then deployed from that stage?
Right, so we talked through the mission profile a little while ago, but it takes just about 9 minutes from T0 to the payload deployment. So it is a pretty zippy flight, although the upper stage runs for about 5 minutes and sometimes can feel like a long time to make sure that to be watching that upper stage.
So continue to wait for additional updates as the team continue to work this hold here. But on that same topic, talking about payload deployment, we should actually go into a little bit more detail about the payloads that are on board. We mentioned that there are 4 CubeSats on board, 3 from universities and 1 from the NASA Johnson Space Center in Houston, Texas. All 4 of them sponsored by NASA through the CubeSat Launch Initiative, also referred to as the Educational Launch of Nanosatellites program, which is that ELaNa 41 designation. And Carolina, can you tell us a little bit about what that program is all about?
Sure. So to start off with a fun fact, the program is actually named after the daughter of Senior Mission Manager Garrett Scrobot, who used to lead the ELaNa missions. So it does stand for Educational Launch of Nanosatellites. And the service is the launch service is provided under a Venture Class Launch Services Demonstration 2 contract. So if you see on the top left of your screen under that NASA meatball logo, you see the mission name is ELaNa 41 and the contract name as well, the VCLS Demo 2. So this contract provides dedicated launch capabilities for smaller payloads and is awarded by the NASA Launch Services Program based at Kennedy Space Center. One of the interesting things about this contract is the venture class missions help further the development and demonstration of new commercial launch vehicles, just like Astra's. The small satellites that we have on board can tolerate a higher level of risk than many larger missions, which help us demonstrate and help mitigate the risks associated with new launch vehicles and really pave the way for new launch vehicles and future small spacecraft missions to move forward. There's also a lot of interesting things about CubeSats. They're playing an increasingly larger role in exploration, technology demonstration, scientific research, and educational investigations at NASA. One of the payloads on board is from Johnson Space Center in Houston. These miniature satellites in general provide a low-cost platform for NASA missions such as planetary space exploration, Earth observation, fundamental Earth and space science, and technology demonstration like cutting-edge laser communications, energy storage, in-space propulsion, and autonomous movement capabilities. Another great thing about CubeSats, just like on our mission, is that educators have economical means to engage students in all phases of satellite development, operation, and data collection. So 3 of our 4 payloads are from universities, and the CSLI provides launch of CubeSat projects designed, built, and operated by students, teachers, and faculty, as well as NASA centers and nonprofits. So overall, to summarize this, missions from the ELaNa program provide a deployment opportunity or rideshare to space, and these program provides spaceflight education and some incredible research capabilities through very small CubeSats. Over the lifetime of the program, since its inception in 2010, the initiative has selected over 200 CubeSat missions, over 100 which have been launched, and more than 30 missions scheduled in the next 12 months. The CubeSats represent 42 states, the District of Columbia, Puerto Rico, and 102 unique organizations. So if you are a student and interested in sending a CubeSat to space, you can check out the NASA CSLI call for proposals, which was most recently in August of 2021.
There we go. So those are those CubeSat payloads that are on board today's flight and on across many missions across the spaceflight industry. Lots of CubeSats going up pretty much all the time, and those makes up a bulk of those small satellite payloads, actually. Of course, the primary objective for today's flight is deploying those CubeSats into low Earth orbit. The targeted orbit, once again, is 41 degrees inclination, so a mid-inclination launch, which is perfect for the Cape Canaveral launch site. Also a 500-kilometer altitude low Earth orbit, circular low Earth orbit. We do have a question in chat from Astra West, who asks, are there any secondary objectives for today beyond payload deployment?
Yes, so as we've mentioned, our primary mission objective today is to successfully deploy those 4 payloads aboard. But we at Astra, we are constantly launching and learning. So we have a number of secondary objectives, mostly for our engineering teams in order to gather more data about their systems and how they operate in space.
Excellent. And of course, that's just part of gaining data from every single flight you fly, right? The more you fly your rocket, you're going to gain data from every flight, and that's always kind of a secondary objective to just keep building that flight heritage.
Yes, exactly. We're, if you want to learn more about our approach in general, you can check out our website, astra.com. We have our newsroom there where we post updates, and you can even check out and read some of the things that we learned from our last missions, LV0006 in August and LV0007 in November, because even if the mission is successful, there's still a lot of things that we can learn.
And we've also got another question here that I picked out from chat myself because I'm a big fan of the space shuttle here. And we've got a space shuttle relevant question, though. James asked a fun hypothetical question, but could Rocket 3 fit inside the space shuttle payload bay? And would the shuttle be able to launch a fully fueled Rocket 3? Well, I've got the dimensions in front of me because I looked this up. And yes, I can confirm that Rocket 3 would fit in the payload bay. The Rocket 3 is 43 feet long, 52 inches in diameter. And you know what? I think I might go to say you could fit multiple Rocket 3s in a space shuttle bay, because the space shuttle had a 60-foot long payload bay and 15-foot diameter payload bay. So yes, absolutely, and someone's got to launch Kerbal Space Program and do this now.
Yes, that is a fantastic question. That is a really fun fact that I'm very glad to have in my back pocket for now. But yes, the rocket that you see in front of you at 43 feet long, it fits inside a standard 45-foot shipping container, which also would have fit in the payload bay of the space shuttle.
And I think, and this is just me kind of spitballing off the top of my head though, I'm pretty sure even fully fueled, the rocket would also still be light enough to be in a shuttle payload bay, because the shuttle was a pretty heavy lifter. And I think it would make for a great two-stage kind of kick-stage deal if you wanted to launch CubeSats to Pluto or something. I don't know, that would be a little ridiculous, but it'd be fun.
Yes, I love that idea. Use the rocket as a kick stage from the space shuttle to send CubeSats far, far away. Yes, I'm not sure exactly the mass capacity of the shuttle, but I reckon that the rocket would be a comfortable passenger on board. Maybe even two of them, as you mentioned.
Yeah. We do have another question. We've got a great view of the ground system, the launcher that the rocket is sitting on. And Tom asks, is that launch mount sat on the ground or does it have foundations? How does that kind of roll out and set up for launch?
Right. So you can see that the rocket is sitting on. I almost just said the shuttle. The rocket is sitting on a black structure. There is a mounting interface with the ground. There are specific sort of hold downs there, and that is how we interface with the ground. But there is no kind of permanently installed foundation aside from the concrete base. That entire structure that you see the rocket sitting on is entirely portable.
Gotcha. Thank you very much. Another question here. Is there a no-fly zone regarding today's launch? I believe that is standard practice here at both Cape Canaveral and other launch ranges. No-fly zones, also marine hazard zones that are maintained, and that's part of that partnership with Space Launch Delta 45, right, Carolina?
Right. So we do work with the range to make sure that not only planes but also boats stay away from the keep out zone. So in the event that we would encounter an aircraft or a boat in that keep out area, that would mean that we would hold until that issue is removed. So we actually have I believe a Coast Guard helicopter who's out making sure that the airways and maritime area is clear for our launch today.
Excellent. We actually caught a glimpse earlier, right before we went live, a Coast Guard helicopter circling the range, and if our friend Steven out there catches that again, we'll try and show that, but the security forces are out in force to ensure that today's launch goes off without a hitch. Another question here asking, how long can this rocket stay in a hold?
Right. So we closely monitor all of the systems. Our launch window does extend to 4 p.m. Eastern time. So we have about 2.5 hours left, I believe, in the in our countdown time. So we have in the past used all that time, and the vehicle has been fine. So we're keeping an eye on everything, but we can be ready to launch at any point within our window.
Gotcha. I keep saying gotcha. I'm doing that thing where I say the same word over and over again. I'll come up with a new response next time you answer a question. But thank you to Carolina for all the expertise here. Andrew with a question asking, what is the typical lifespan of a CubeSat?
Yeah, so I'm not a CubeSat expert here. More focused on the rocket and the rest of the launch system. However, CubeSats can be pretty resilient and live live quite a long time. One of the depending factors is how much time it can spend on orbit before the orbit decays, of course. But CubeSats can have a lifespan of many years.
And yeah, the CubeSats are also designed to be sort of a low-cost access to solution to space, which means that they are tailored towards, short-term missions in low Earth orbit. Usually, some CubeSats are designed to last a long time. CubeSats have been sent to Mars, for example, but most of them operate in low Earth orbit and operate pretty short missions. But that also means there's potential for an extended mission, because if you plan for, let's say, a month-long mission, and then after a month the CubeSat's still working, well, you can go get extra data, you can keep doing the mission, you could even do a different mission using the same instruments or whatever. So there's some factors that play into that, but the CubeSats all have different varying mission requirements and things like that, but that orbital decay is a big thing because most of them don't have propulsion on board. Not all, but most of them don't, which means you can't boost your orbit. You're kind of at the mercy of physics, if you will. But definitely an interesting point to talk about. Another question here from Taylor asking, how many Rocket 3s will there be, and is there another rocket in the works?
Well, there's always another rocket in the works here at Astra. And we have a lot of exciting plans. Today we are focused on this very exciting launch of LV0008, which represents a lot of firsts for us at Astra. It will be our first mission where we will be deploying a payload. We are, of course, having our first launch from Cape Canaveral. If you've joined us in the past, the view is a little different from our regular launch site in Kodiak, Alaska. And so we're focused on today's mission, but if you want to keep track on Astra's future plans, you can check out our website, astra.com, and follow us on social media as well.
Looking forward to many rockets in the future. Coming up on hopefully releasing a hold before too long. Yeah, we're standing by for another update. The launch teams are currently in a hold. I'm just sitting here blabbering my mouth about it. But the launch teams are currently in a hold, and we're going to stand by for a further update here. Again, the launch window extends until 4 o'clock p.m. Eastern Time. Plenty of time to resolve this. So let's go ahead and listen into the countdown net and wait for another update from Mission Control.
This is Astra Flight on countdown. Astra is picking the count back up at T-minus 15 minutes at this time. And re-entering terminal count. CDH confirmed for me that the first stage fuel tank is full and we do not require additional filling.
Confirmed.
Per step 146, Tango, please inspect launch machine to prepare to set a new UTC T0 time.
Ready.
New UTC T0 time is hours 18,
1-8.
minutes 50,
Minutes 50.
seconds 00.
Seconds 00.
Please save and commit.
Save and committing now.
And as you have just seen and heard, we have resumed our countdown, and we are just inside 14 minutes from our new T0 time, which is 10:50 a.m. Pacific time, 1:50 p.m. Eastern time. And the team is proceeding into the final steps of preparing the vehicle for launch, our terminal count. In just a few moments, we'll hear our go, no-go poll with our final preparations, and after that point, we will be in just a few minutes away from our T0.
Looking forward to liftoff as the clocks are now ticking once again and are heading towards that new T0 again, 1:50 p.m. Eastern Time, 1850 UTC. We can go ahead and listen into the countdown as they work through some more procedures coming up on that go, no-go poll. Let's listen in.
Activating AUX1 OV 201 first fill.
AUX1 OV 401 fill.
Deactivating AUX1 OV 401 fill.
AUX1 OV 301 upper fill.
Deactivating AUX1 OV 301 upper fill.
In machine fuel 4 operate, toggle off first and full.
Toggling off first. Toggling off full.
Please deactivate fuel 4 operate.
Deactivating fuel 4 operate.
Fuel 3 supply.
Deactivating fuel 3 supply.
Fuel 1 FV 300 upper fill.
Deactivating fuel 1 FV 300 upper fill.
Fuel 1 FV 200 first fill.
Deactivating fuel 1 FV 200 first fill.
AV1 radios.
Deactivating AV1 radios.
And deactivate AV1 rocket support cart.
Deactivating AV1 rocket support cart.
Please confirm for me that the following machines are still enabled and running. Zero stop purging.
Confirmed.
AV1 manage polling.
Confirmed.
AV1 manage power systems.
Confirmed.
The entire helium stack.
Confirmed.
Please activate machine igniter 1 spark test.
Activating igniter 1 spark test.
VB1 first stage power.
VB1 first stage power is activated.
VB1 upper stage power.
Activated.
VB1 turn on off PDBs.
Activated.
And water 1 water system.
Activated.
Tango, please activate launch machine.
Activating launch.
Please toggle locks topping at this time.
Toggling locks topping.
Per step 151, this is the Astra poll for tank pressurization and launch. After this point, any system issue must be called as a 3-word hold. That is a hold, hold, hold over the net. If there are no concerns for flight, call go. Otherwise, call no go. Red lead.
Red lead is go.
FTS.
FTS is go.
Delphin.
Delphin is go.
Ether.
Ether is go.
Odin.
Odin is go.
Inco.
Inco is go.
Ace.
Ace is go.
Launcher.
Launcher is go.
Orbit.
Orbit is go.
Booster.
Booster is go.
GNC.
GNC is go.
FAO.
FAO is go.
CDH.
CDH is go.
Tango.
Tango is go.
Safety.
Safety is go.
Flight is go as well at this time. Tango
As
in
you just
EV1
heard.
manage polling, please toggle do only ground polling.
Toggling do only ground polling.
Teams have pulled
And
go
Tango,
for the
next
launch.
up we're going to load
So as you just heard, sorry, don't want to talk over the flight director there, but the teams have pulled go for launch. 9.5 minutes to go for a target liftoff time of 1:50 p.m. Eastern Time. Teams are going to be working through the rest of the terminal count here as all systems are go, including the range, weather, and the rocket itself. Carolina, how are you feeling over in Alameda?
The anticipation is certainly building over here in our final minutes before launch.
Why don't we give a brief update, or not an update, an overview of the mission timeline since we are now into the business end of the countdown.
Yes.
First things first. Yep, go ahead, Carolina.
Sure. You can see the mission timeline up on your screen, and at T-minus 3 seconds, those 5 first-stage Delphin engines will ignite before our liftoff at T0, and then we will very quickly begin our pitch-over maneuver at T+6 seconds. If all goes well, we'll reach max Q at about 1 minute and 10 seconds. That's the point of maximum aerodynamic pressure on the vehicle and a very significant milestone. And then in very quick succession, we have main engine cutoff, or MECO, fairing separation, and stage separation. And then just around 3 minutes and 5 seconds into flight, we have our upper stage ignition of our ether engine. And then ether will burn for about 5.5 minutes before second engine cutoff, or SECO. And finally, we will deploy our 4 payloads, our 4 CubeSat payloads at 8 minutes and 40 seconds after launch.
And that will be a deployment sequence of a couple seconds between each satellite before CubeSats all deployed in quick succession, and we are hoping that we get there in just about, well, 8 minutes of countdown and then 8 minutes of flight to orbit, so about 16 minutes or so, hoping to be on orbit and delivering those payloads. That would be an awesome sight to see. Again, if you are just joining us, this is Astra's first launch carrying payloads, actual satellites, into low Earth orbit. Also the first launch from Space Launch Complex 46 here on the Space Coast at Cape Canaveral, Florida. Liftoff is targeted for 1:50 p.m. Eastern Time, 7.5 minutes to go. And you're listening to live coverage from NASA Spaceflight Thomas Burckhardt here at Cape Canaveral and Carolina Grossman at Astra's headquarters in Alameda, California. Let's go ahead and listen back into the countdown net as the teams go through their final points. Should also point out that boat in the background is not an issue. That is outside the exclusion zone. Just realized you might see that in the view. I promise. The range is green, I'm told. The rocket is actually flying a different direction, so all good here. But yeah, as the teams get through these final steps, let's go ahead and listen back into the countdown net.
V1 manage polling, toggle do both ground and guidance polling.
Toggling do both ground and guidance polling.
Delphin confirmed GSE igniter system is ready for launch.
Igniters are in good state and good for launch.
FTS, issue logic on AFTU, verify CAS is green and nominal.
Stand by. AFTU is logic enabled and master enabled.
Copy. Tango, verify vehicle looks ready for launch aside from tank pressures.
Vehicle is ready for launch.
Rock, this is flight on countdown.
Rock.
Astra is looking for final range green and launch authorization for this morning.
Range green.
And you just heard the Cape Canaveral Space Force Station range has confirmed range is green for launch.
Tango in the launch
Could be up-
machine, please toggle launch.
Enabling launch.
Coming up off 5 minutes, Flight Director Chris Hoffman will give the final briefings ahead of the final business end of the countdown, and the rocket is, before too long, going to be taking over internal control of the countdown itself and getting towards liftoff.
5 minutes. Flight on countdown with a reminder to all that any 3-word hold call from here on out is an immediate abort regardless of source. Minutes.
Under 4 minutes to go to the launch of the ELaNa 41 mission on Astra Rocket 3 LV0008.
Rock, flight on countdown.
Rock.
Please verify the range is recording telemetry at this time.
Verified.
Thank you, sir. And a reminder to all Astra personnel, control room, if you require RF data, be prepared to switch over your Grafana sources at liftoff. MIFCO, flight on countdown.
MIFCO.
MIFCO, prepare to issue option when rocket IIP marker passes min-MECO point and is within dispersed trajectories. Call out at time.
MIFCO copies.
3 minutes.
There's a great view of the Astra teams in Alameda watching today's launch. 2.5 minutes to go.
FTS at this time, send master, enable, and watchdog on AFTU.
Watchdog is enabled.
Thank you. Two minutes.
Now passing 2 minutes till launch. Again, this is the launch of the ELaNa 41 mission for NASA. 4 CubeSats hitching a ride on Rocket 3.3 LV0008, Astra's first mission with satellites on board. Ready to lift off from Cape Canaveral, Florida in just under 2 minutes from now. Coming up on 90 seconds.
90 seconds.
I'm going to leave commentary in the hands of Carolina Grossman at Alameda's headquarters, and good luck and Godspeed to LV0008.
Enjoy the view, Thomas.
Ace, flight on countdown.
Ace here.
Please start PSD recordings and downrange ground station recordings.
In work.
"60 seconds. Vehicles on internals. "45 seconds. First stage tanks coming up to pressure. "35. Vehicle is at pre-liftoff tank pressures. 30 seconds. "20. 15. 10. 9. 8. 7. 6. 5. 4. 3. Imagination 1, 0. Abort.
As you've just
Launch
heard,
is
we had an
deactivated.
abort at T0. Teams will look into the data, and we have time to try again. So right now the team is getting the vehicle into a safe state as we look at the issue that triggered the abort. If we are able to reset the countdown, we would pick up again at our terminal count point of T minus 15 minutes. And we do have time in today's launch window, which extends until 4 p.m. Eastern.
Copy. In work.
And as you saw, there was an abort at our T0 liftoff time. Looks like we did have engine ignition and an abort was called. The teams are troubleshooting the issue. Looks like the pad is safe and secure, no fires, no issues on the ground. So thanks for standing by while the team looks at what happened in the final moments of our terminal count. And we will keep you posted with updates as soon as we can. If we are able to recycle today's launch attempt, we would resume from T minus 15 minutes, the top of our terminal count. And we do have until 4 p.m. Eastern today in our launch window.
And whether that recycle can occur will of course depend on the issue itself and how it can be resolved. So we'll stay tuned for those updates. But like Carolina said, launch window does extend for a couple more hours, so we're going to stay tuned and see what our status is, and we'll share that as soon as we have it. We actually did talk about this a little bit earlier in the broadcast, how the rocket is, of course, designed to handle multiple fueling and ignition cycles. We were talking about the engine static fire test, which is a planned milestone before every launch to make sure that the systems are all healthy, goes through an entire countdown. And so the rocket does have that recycle capability, but just depends on what the actual hold or the abort was triggered by. But those aborts are all triggered by onboard commands, right, Carolina's onboard computer sensing something is not quite right.
That's right. So at T minus 60 seconds, you heard that call out that the vehicle is on internal control, and it's all systems within the vehicle that are monitoring and making sure that everything is as it should. And if it isn't, an abort is triggered. So that's exactly what happened. That is, the system is working exactly as it should. And so we can look at what caused the specific abort that was called, and the teams are already beginning to look through the data and troubleshoot.
You can see that countdown clock stuck at 13 seconds. We'll expect to see that, of course, recycle if a recycle is feasible. Standing by for word on that, but that clock is holding right now as the teams assess the abort. While we wait for more status, we can go ahead and get back into questions. If you have any questions about today's mission, please tag at NASA Spaceflight in chat, and we're going to go ahead and try to answer those and keep providing some more information on the mission. We'll also keep those updates forthcoming, though, as we have them. The next question, someone is asking, what happens if there's a range violation after liftoff? Does that warrant an FTS activation?
Right, so if there is an issue after liftoff, we do have a flight safety system, or FTS, flight termination system, that is on board the vehicle. And so the FTS system would be activated if, for example, the vehicle is drifting off course, and would ensure that we stay in the safe area. We make sure that the keep out zones are clear before we launch, to make sure that everyone on the ground, in the air, is as far away from the rocket as they need to be.
Yeah, those range borders are actually monitored, not just those inside the hazard zones, but any vehicles that may be approaching the hazard zone too. So it's not ensuring the hazard zone is clear at liftoff, but then the question being about what if a range violation occurs afterwards? Well, the relevant authorities are also looking at any nearby vehicles that could reach the hazard zone during, shortly after liftoff, and making sure that they're all clear as well. So that's all coordinated and ensure that that will not take place once the rocket's actually in the air. Another question here from Daniel asking, can Rocket 3 launch in the rain?
Yeah, that's a great question. So there are lots of weather conditions that we keep in mind in order to ensure a safe and successful launch. A big one is lightning. There's a big lightning protection system around the rocket, which is so large you can't really even see it in the frame right now.
Mm-hmm.
We also keep an eye on winds. That was the reason for a hold earlier. But rain itself actually isn't that big of a problem. It's all of the typical bad weather effects that come along with rain, such as lightning and wind.
It would be appropriate for someone to ask what those towers are for, right? But I think we preempted that question by talking about lightning protection a couple times. You can see in this frame there are some cables running down on the left and right hand side of the rocket. Those are part of the lightning protection systems. They run up to the towers. And then here's a great view from Jetty Park, and you can see those two lighting towers more clearly there, along with the mobile service tower, which is of course not in use for Astra's rocket, but has been used for other launches from Complex 46. Another question here from Skysurfer, who asks, during a launch, do the cables, hoses, and electronics on that strong back get damaged from the heat?
Right, that's a great question. So we do everything that we can to protect the system from that engine plume, those very hot gases that are exiting the first stage as the vehicle lifts off. We do, since we light the engines a few seconds before T0, as well as conducting a static fire test of a few seconds duration before we make any launch attempt at all. We do our best to protect all of the cabling, hosing, electronics, etc., and do maintenance as needed for the bits that get a bit crispy.
Gotcha. So seeing some questions in chat about the venting that you can see on the screen. That is not them detanking the vehicle, right, Carolina? That's just nominal, just sort of stable replenish venting.
Right, that's correct. So we pressurize the tanks a few minutes before our T0 time, so we vent to make sure that we can keep the vehicle safe and in a stable state while it's on the ground, while the team is troubleshooting the issue that caused the abort right around T0.
And on that front, the ground equipment will be able to top off those fuel tanks continuously, right? That's still taking place, especially after a recycle.
Right. We will make sure that we're able to reach the appropriate levels and top off the tanks as needed.
Again, if you're just joining us, this is the launch of ELaNa 41, a CubeSat mission for NASA, 4 CubeSats on board. The launch was just aborted right about a moment before liftoff, and the teams are currently working to assess that abort and determine if a recycle will be able to occur. We'll provide that update as soon as we have it.
Thanks for standing by with us. If you're just joining us, we had an abort call just a few seconds before liftoff, and the team has been working to troubleshoot the issue. We are at this point keeping all of our options open, and we would recycle. You can see the clock's been reset preemptively to T-minus 15 minutes and holding there. So we would recycle our countdown from the beginning of our terminal count at T-minus 15 minutes. We'll continue to give you updates as we have them, but the team is keeping our options open and hoping to recycle today. And thanks for standing by. If you are just joining us or waiting along with us, we had an abort right around T0 of our launch attempt. The team has spent the last approximately 45 minutes looking through the issue, and we are doing some final tests to see if we will be able to attempt to recycle today's launch attempt. We have about an hour and 15 minutes remaining in the launch window, and we would pick up the count from T-minus 15 minutes, so plenty of time to try again if we're able, and we're just standing by to see if the team is able to successfully complete the final test before picking up the count again.